Hello students, we're about to begin our studies of Strand 5 in the Senior Cycle Maths curriculum on functions. Why, you may wonder, do we need to study functions, and what exactly are they? I have chosen to give you an overview on functions today for a number of reasons. Functions are a core concept in the study of maths. At Senior Cycle we will expand on your existing knowledge of functions that was first introduced to you, maybe without proper explanation, at the Junior Cycle level when you first initially started to look at algebra. Functions appear in numerous maths topics such as algebra and calculus, and by the time you start calculus you should have a good grasp on functions and how to apply their use to difficult problems. Questions on functions come up yearly in the Leaving Cert, which further highlights their importance, and there is also strong cross-curricular links between functions and other subjects, particularly the sciences. As we go through this podcast on functions, there's a few learning outcomes I would like you to achieve. Firstly, as you will already have touched on functions at the junior level, you may be familiar with some of the language. As we develop our knowledge, I will introduce some new mathematical terms, some of which will appear in this presentation. So by the end of the podcast, I want you to have identified some of the terms that are new to you. Secondly, there's no point in discussing functions if you can't identify one. So by the end of the presentation, not only should you be able to identify a function, but possibly differentiate between them also. Thirdly, I want you to appreciate how important a role functions play in the senior curriculum, and that cross-curricular links with other subjects such as science exist. And finally, I want you to identify how some of the key skills of the senior cycle curriculum are developed during the topic. Before we go further into the topic, we will refresh your memory on your existing knowledge relating to functions. Being able to verbally describe what a function is goes a long way to help you understand the topic. A function is simply a relationship between two objects. Each object in the first group is called an input, and it corresponds to exactly one object in the second group called an output. This is an activity you'll be doing yourself during one of the classes where I will get you all to write in your own words what a function is. A simpler, less precise way of looking at what a function is can be shown in the animation below. A function is applied to an input value of 3. This function simply requires that any input is doubled, and so we get an output of 6. Depending on the section of functions we are covering, I will incorporate different teaching techniques where possible. For example, when we start a topic, we can investigate different case studies and you will work together to define if something is a function or not. For example, if bread goes into a toaster and the output is toast, is the toaster acting as a function? Is it changing the input to something different? As the classes progress, we will use visual aids such as making a poster for function notation or YouTube videos for further explanations, and you will work together to solve problems. As we get into the graphing of quadratic, cubic and exponential functions, we can use tools on the whiteboard, or you can even use them at home, such as GeoGebra. All these different techniques should help us to develop better understanding of functions. We already know that a function is a relationship between two objects, an input and an output, where there is only one output for each input. At Senior Cycle, you'll be breaking this down even further and discussing the different types of functions, such as surjective, injective and bijective functions. Surjective functions, as it says in the blue box, are those functions in which every output element in the codomain is associated with at least one element of the domain. This is shown in our mapping diagram where the output value of 9 has two possible different input values of 2 and 3. Injective functions are the opposite, as the output element in the codomain has only one input associated with it, as shown in the associated mapping diagram. You can have elements of the codomain with no associated input value. For example, in our mapping diagram, the value 3 has no associated input. Bijective functions can be both injective and surjective, and in a bijective function, every element of the codomain has exactly one input element, as shown in the associated mapping diagram in red. During the study of functions, we will be dealing with the sketching of graphs related to a function. The important features of any graph you will be working on include the shape of the graph, i.e. whether it's a quadratic parabola or a double curved cubic equation, the points where the graph crosses the x and y axis, and the turning points of the quadratic and cubic graphs. When dealing with quadratic functions, we will need to express the function in completed square form, and this will allow us to find the turning points of the graph. Similarly, you will sketch cubic function graphs by finding where the curve intersects the axes and the turning points. Any function that follows the form f of x is equal to a to the power of x, where the base a is a positive real number other than 1, is called an exponential function. In the senior cycle, you will be investigating exponential functions where a is greater than 1 and where a is between 0 and 1. The graph of an exponential curve is very recognizable, and as you can see on the screen, the value of a dictates the way in which the graph faces. Using the program GeoGebra that we mentioned earlier for the active learning in the classroom while covering graphs will allow us to change coefficients and other factors and dynamically see how these changes affect our graph. This will allow us to visualize the function even better. Cross-curricular themes are evident between physics and functions. Many experiments investigate the relationships between inputs and outputs and ask the students to graph the corresponding results. Those of you who are studying physics will have come across exponential graphs before, particularly when investigating the chapters on nuclear physics and resistance. The experiment on Joule's law is one of the mandatory experiments in the physics curriculum. The experiment uses functions in a practical sense in that it has students using linear functions in the form y equals mx plus c to develop the relationship between the current and temperature changes. Studying functions offers ample opportunities to develop some of the senior cycle key skills. Working in a group is about communicating effectively, contributing ideas, listening and receiving feedback, and leading or following as appropriate. During the study of functions, students will work in groups for think, pair, share activities, case studies, and will have discussions on why functions should or should not be classified as surjective, injective, or bijective. These varying activities will provide lots of opportunities for students to develop their communication and group work skills. While you study other strands of mathematics, you'll be given a lot of information to process and critically evaluate. This is no different during the study of functions. However, developing the skills to be able to process this information and then creatively and critically assess it so you can think through a problem are skills that will not only help you in maths, but will also help you in other areas of your life. For example, while I have been talking to you, you've more than likely been listening to what I'm saying while simultaneously processing the information on the screen. Functions will provide numerous opportunities to further develop creative thinking and information processing skills, many of which are listed on the display you've just been reading. In July 2011, the then Minister for Education, Rory Quinn, launched a programme for the development of literacy and numeracy of students. Maths is a natural development ground for numeracy skills, and during the study of functions, you'll be interpreting data in different formats such as graphs or equations, observing numerical relationships between inputs and outputs, recording and displaying data, and through these actions you'll be developing your mathematical skills and understandings. Literacy is also going to be developed during our study of functions through practices such as describing verbally what a function is, explaining your own ideas and concepts with the proper use of mathematical language, and being made comfortable enough so that you actually use this new language regularly. This is the final page of our podcast, and hopefully you will have reached some, if not all, of the outcomes outlined at the start. You should be aware of some of the new terms you're going to come across, such as functions, exponentials, domain, maybe codomains. You should also be able to identify the graphs of a quadratic, cubic, or exponential function. Also, hopefully by now you should be able to identify an area where cross-curricular links exist, such as we mentioned earlier, the physics experiments. And you should be able to identify how our studies of functions will develop the key skills at a senior cycle level. Thanks for listening, and I hope you enjoy your future studies in the topic of functions.